Hey you guys, and welcome back to another video from Warehouse Amps. We've got an Ampeg V4b bass amp in for repair. Owner says that it has a pretty bad hum going on, 60 cycle. So we're gonna check that out and then do a full service on it as well and get it back into fighting shape. First thing we'll do is we're gonna plug it in and just see how bad this hum really is. All right, we warmed up the amp and turned it on, and it definitely has a hum, as you can hear. And it has a little bit of that frying egg sound as well. Seems to be more pronounced in the volume 2 pot. And a little bit of dirt there. Great, so we'll start getting this thing pulled apart and see if we can't take care of that for the customer. Well, here's the underside of the V4. I went ahead and removed the tubes just to get it out of the chassis safely, get it out of the head box safely. We've got cap canisters, there's 3 of them. This looks a little damaged, melted perhaps. These are interesting because they are wrapped in paper here. There's these 2 guys and then a 3rd one over here. And this one is also kind of smashed up a little damaged. And I don't believe that these are covers. I believe these are the actual exteriors of the cap cans, and they are riveted in. Which is interesting, and it's that F board material, that green material that some of us use to make turret boards out of, me included. Okay, and then power tubes, looks like they used to have the little bear trap claws on them, but they've broken off or someone's pulled them off, and that doesn't look too safe, having that guy poking in there, so I might deal with these guys a little bit. And then yeah, there's actually more tubes listed on the back of the amplifier than there are that you can get to from the bottom. Let me flip this camera around here. You can see that for this section it says this is the back row, or I guess near the front of the amplifier, 12AX7 6K11, which was here, and then we have another 12AX7 and then a 6CG7, which I'm assuming is somewhere inside here, a 12DW7, which is in the front section back here, and then another 12AX7 which will be in here somewhere, unless those are for the guitar amp version and they don't need them for the bass version, and they would have been here. We'll find out more once we open up the chassis itself and get a view from the top down. All right, I was just looking up these can capacitors to figure out, if I could, how old they are. The amp itself is a 73, and then the cans do have an EIA number on them, so it's upside down. It's 1160. Which is for the company, and then 1972, here's the focus, and then the 35th week. So
I didn't get that. Could you try again?
Sorry. So these are the original can capacitors for the amp, which means they're over 50 years old, which means we're going to get new ones because that's really old. The only bummer part is that they are riveted in, which shouldn't be too hard to take care of. Just drill out the rivets, but then I'm not sure how the new cans are gonna look. Might have to dig around a little bit to find something that's gonna line up well with what we've got to work with here. Also, it looks like someone has replaced some resistors between these cap canisters and has added this little guy, which was probably to replace a very large resistor or a capacitor that used to live here that was like about the size of a half stick of dynamite, and it looks like it overheated at some point and maybe even detonated, who knows. But that's what all this scorching is about. Is there's usually a big capacitor that lives here, very high voltage, and does filtration for this circuit board. So I'm guessing that's what this replacement is for. We'll most likely keep it. I'll just disconnect it and test it before I make that decision. So we're gonna order these two filter capacitor cans, and then this third one over here, which looks like it's supplying power primarily for the output transformer, which is there. So these two do filtering for the main transformer, and then this guy over here for the output transformer. All right, good news. It looks like someone has already, let me get this out of the way, put in some new can capacitors. They had slipped these sleeves back over the top and glued them on, so that was a little misleading. But there are, I assume, 3. I can't get this one to come off, so I'm just gonna leave it. 3 new can capacitors in here, and they do appear to be wired correctly. It took me a couple of minutes to understand how these are wired, and I'm going to explain it to you really quick before I forget how it's done. For the filtration of the B+, the high voltage power, we've got a line coming in here from the 4-way rectifier. It's going into this first can capacitor, which is 70 microfarads. It's also connected to this 40. So these two are acting together. And then we've got a 100K resistor over to this can capacitor into a 40. And then that's also connected over here to another 70. And then both of these are connected back to the negative side of this can capacitor. Okay, so we're linking these guys together, positive to negative. Okay, so now the negative side of this can capacitor is actually positive. Okay, we've got another 100K that goes to the ground, or what is now the positive side of this cap can, and then comes out and returns here to the circuit. All right, kind of confusing, but basically we're using these 2 canisters to create a 70 and 70, 40 and 40 reservoir caps. All right, so we're doubling the voltage, and we are combining the capacitance in order to have a larger reservoir of power to draw from. It's a pretty weird way to lay it out, but it finally kind of makes sense to me now, especially since you see this floating capacitor is coming off of a positive lead here to a negative lead here, and then another positive lead here, and then into where it says B here. So supplying some other high voltage to the circuit. Okay, this is in a microcosm what's happening over here. We have a capacitor that is taking voltage from the negative to the positive to the negative to the positive, and then supplying it to the circuit. All right, so I don't need to change these out. They're wired correctly. The components look good. We're good to go there. So my next step in alleviating this hum is going to be rewiring getting the primary circuit wired correctly. Right now, the hot wire comes straight to the fuse, and then up to the switch, and then to this terminal strip to energize the transformer. But what we want to do is actually come in and go directly to the switch, then here to the fuse, and then to the transformer. Okay, that is because when the switch is off, we don't want any power in the system. The way it's wired right now, the switch could be off, but there still would be power here. Okay, so if the amplifier was plugged in, a person could touch this and be shocked, or if they were just checking the fuse, they could get shocked. All right, so we're gonna fix that. We're gonna take this grounding wire that's soldered to one of these output tube shells, and we're gonna ground it directly to one of these bolts on the transformer. Right now, there's about 2 ohms of resistance between this grounding wire and the chassis. So that's not good. That hopefully will help us with our hum situation. So we'll run this to here and bolt it down nice and tight. The neutral wire will basically continue it on its same path in a twisted pair where it's going right here up to this lug and energizing the transformer. If we don't get much hum relief from rewiring the primary circuit, then I'm going to come back and tackle these heating wires. We've got heater wires that are running along the back wall. They're not twisted, and they're not, you know, in the traditional Fender way, coming up and over and down again, helping to reduce the amount of electromagnetism that can be created by these 6-volt heater wires. So we'll do the primary circuit, and then if it's still humming pretty bad, we're going to replace these heater wires with some that are a little better in terms of reducing hum. All right, guys, here's an update on the Ampeg V4b that was humming. Made a few changes here. I redid the primary circuit, so now we've got a properly grounded wire from the power cord. You can see I've got it on one of the lugs of the transformer, and I also scraped away the paint so that it would make good contact with the chassis. And then I ended up going into the fuse first from the hot from the power cord, just because it's such a long travel to get up to where the switch is and then come all the way back and then go all the way back up again to this turret board where everything's running out of. I just went straight in here, but I did cover the 2 terminals with heat shrink to help with the possibility of electric shock. And then we've got a tightly twisted pair of AC wires leading up to our boards, going to the switch for power. I disconnected the polarity switch because we're not using that anymore. And then we've got our indicator lights, our indicator light plugged in here for power. And then over here we have the neutral coming in. And then we also have our indicator light and switch for standby. Okay, all of that remained pretty much the same. I also went ahead and replaced the large resistors underneath here. We're looking at R39, 46, etc. These 4 are the plate resistors for plate resistors for the output tubes. All 4 of them were showing a different ohm rating, so that's not cool. So we replaced all of those with 5-watt, 10 ohm resistors. And then also there was a large resistor here, R55, which is handling the B+ input that's coming in for the circuit. And so that one was a little smoky. As you can see from the top, there's been a lot of heat discharge. So I replaced that one with the appropriate value. And then I double checked all the capacitors. Everything's wired correctly and working correctly, even though the way Ampeg does it is kind of bizarre. I think I understand it now, so I'm not going to change any of that. The main culprit, by the way, adding that ground lead did help quite a bit with the hum, but there's still some hum in the system. The main culprit that I found is that this amplifier is not grounded very well. We've got a single lead coming off of this board, this black wire traveling back here. It's tied in to all of the power tube sockets on pin 8, the cathode. Those are all tied together to this wire, and then it continues on all the way over here to the output speaker jacks and is grounded to the output jacks, and they are not in contact, or were not in contact, with the chassis. They had little rubber bushings on them, and then some rubber washers on the outside, so that they were floating in these holes and not making any contact. Plus, everything's painted. So basically, there was just a whole lot of energy that needed to get to ground, and it wasn't getting there in an efficient way because nothing was connected to the chassis. So what I did is sanded back the paint here and took off the rubber grommets and all that stuff. And I'm just gonna like put these back in with star washers so that we have good contact and we can get this signal to ground. Now, the way I figured that out was just by testing, running a lead from this bolt here, which is part of the output transformer, to the negative terminal on these speaker outputs. And a whole bunch of the buzz went away, a whole bunch of that hum, that 60 cycle. So that's kind of how I figured that out. And then I started tracing back all of this grounding lead and realizing that like none of it was actually going to the chassis. Now, that's probably part of the original design because there are no center taps on the high voltage or on the 6.3 heater lines coming out, which, that's kind of weird, but maybe Ampeg loves doing it that way. That just means that everything was kind of a floating ground in here. Even the chassis on these cap cans are not touching ground. They're in these little boards so that they can't be grounded. And so if you're running a 2-prong cord in, then you've got your positive or your hot coming in and then your neutral going out, and that's, I guess, all you need. Once you introduce a 3-prong cable and then you're going to ground to chassis, well, now you need everything else to ground to chassis. And if there's no center tap, that makes it a little more difficult to get rid of all the hum. So we're going to reinstall these speaker jacks and ground it to the chassis, just like the 3-prong power cord is, and see where we're at with the hum. If it's super quiet, we're going to call it good there and do an audio test. And if there's still a little bit of hum left, we're going to see if we need to ground to some additional points from maybe one of these boards to the chassis somewhere else. Okay, well, I think we've done just about all we can here. Final steps was to this grounding of the output plugs worked to a limited degree. There's still some hum, but this helped for sure. So the final step was to go ahead and replace all of the 6-volt heater lines with twisted heater lines. So we've got it coming out of the transformer, twisted and coming in from above, and then from one output tube to the next, all the heating elements have this twisted wire. One thing to watch out for with a system like this one, or I guess really any system where you're linking together multiple output tubes, is make sure that you are using the same lugs with the same wire. Okay, so if you start here on pin 7 and you twist it, that same wire needs to go to pin 7 on the next tube, okay, and on and on. If you don't, then the hum balance, when you hook that back up, it's not going to work properly, okay? The hum balance is basically allowing you to send more or less voltage to ground on these two lines, okay? So in order to get the voltages even on either side of the tube, you have to maintain the same connections from pin to pin to pin to pin. All right, well, we're going to put this back in the cabinet and do an audio test with a dual 15 speaker and a bass to see what it sounds like. All right, the Ampeg is back on the bench. I did an audio test and the hum is still too loud. So I'm going back through the biasing procedure. I was noticing that the negative DC voltage to the grids control grids was not high enough, according to the schematic. It was about 10 volts low, and the bias of the tubes is too hot. Not by a ton, but enough. So we're going to try to increase the negative DC voltage from this section of the amplifier. Let me grab my pointer here. We've got our diodes, our four-way rectifier right here. There's some filtering happening, and this is the first step in that circuit. It's a 0.047. It looks like it's been replaced, but it also looks a little cooked. So we're going to replace this guy, and we're going to replace these two 10 at 100 volts with some 10 at 250, because all the voltages in this amp just seem to be out of control. So just to be safe, we're going to pull these. These guys didn't measure very well, and you can see a little bit of stuff leaking out of this guy. So we're gonna replace these two, and then we're gonna replace the resistors in that circuit as well. So these two and this guy. This one is really the one. It's a 10K that sort of sets the voltage going to the control grids. So we may end up increasing this value in order to get more negative voltage to the tubes. But first we're just going to replace these components and then remeasure what our output is, what our negative DC is to the tubes. And hopefully it'll go up a little bit and get real close to that negative 65 that they want according to the schematic, instead of where we are right now, which is about 55. Okay, and we'll check back when I've got that worked up. Okay, replaced some of those components. You can see we've got the new 10 at 250 capacitors, went up to a 250 just in case, and then we've got the new 0.047 over here at 600 volts. Things are much quieter now. There's still a little buzz, a little hum happening. So we're going to keep working on it. But also, our DC voltage has gone up, which is good. We've got about 60 right now, almost 61 negative volts. We're shooting for 64 total. And right now I've just got a jumper coming from this resistor over to the next set of resistors in the schematic. Let me point it out to you here. Okay, so we replaced this filter cap, 0.047, these two 10 at 100s. These two resistors checked out. They were in good shape. This is the one that I've unclipped here, and it's also in spec, so it's a 10K right now. And we're jumpering it over to this point here, to these two 100Ks that feed into the plates. So right now, what I'm gonna do is increase the resistance here. I've just got a new little toy, a decade resistance box, so I can add in different resistances and then check the negative DC voltage to see how it's going. So I'm gonna put this into the circuit, and then we're gonna see what sort of resistance would be ideal to get that negative DC up to 64. Okay, so I'm trying an 82K resistor. So I'm bypassing the 75 and going to ground. And I've had the amp on for a few minutes, and we're gonna check to see what our voltage is with 82K of resistance. And we're at 64.2. So I'm gonna call that good. So we'll substitute in this 82K for the 75, and we should have a good, healthy negative DC bias voltage. All right, so we've got our 82K resistor installed, And now the negative DC bias voltage is stable at around 64 volts negative, just like the schematic asked us to do. And then I went ahead and replaced all of the coupling capacitors and a couple of the smaller value capacitors for the tone circuit. Now I'm going to flip this back over and do one more bias check to see where we're at with these 7027s. Got my adjustable bias put in here, basically just interrupting R49, which was the bias resistor in the negative DC bias circuit, and we brought it out here to a 100K pot. There's an 18K resistor in line also. That's because I don't want this to ever go to zero. That would cause the tubes to run away and explode. So we're the very minimum, you know, we would have in this circuit is 18K. Right now I've got it adjusted so that my negative DC bias is 60 volts. Schematic calls for 64, and that's just too hot for these 7027s. So we've got negative 60 DC volts, and after I took a plate current measurement and did the math, over here we see that we ended up with 24.7 watts, which is just about 70% of the tube's 35 watt maximum output. So that's right where we want to be. Next step is to deal with some of the residual noise that we have. There's a little bit of a frying egg sound happening, and just a cursory test, I removed V1, it did not go away. I removed V2, it did not go away. I removed V3 and it did go away. So what I'm going to check now are the resistors in line for the plate current that's being provided to V3, because those plate current resistors are the ones that typically make that frying egg sound. So I'm just going to check them to see if they're working properly. You can see V3 is this 12 DW7. It's getting 325 volts from this rail. So I'm going to go all the way back to here and check this resistor just to make sure, because these guys have their own resistors. This one does not. It's relying on this guy. And then I will check this resistor for the second half of the same tube to make sure it is functioning and doing what it's supposed to. All right, so after replacing a few more resistors, plate resistors, and also a couple or 4 grid resistors on the output tubes, we have a very, very quiet amplifier now. There's no more frying egg sound, and the 60 or 120 cycle hum is extremely low. So we're going to call this guy finished. I just wanted to review everything we did real quick before I put it back into the head and do an audio demonstration with the bass cabinet. So I'll just point out a few of the things real quick that we did in order to get rid of the hum in this amplifier. We installed twisted 6-volt wires for all of the tube filaments. Remember, these wires were originally just run along the back wall and then they came directly in. That was opening up these output tubes to electro-harmonic interference. We also brought the power cord in a little further and grounded it to chassis. As you remember before, it was grounded to this tube's socket, which was not a great way to do it. We redid the primary circuit with tightly wound hot and neutral leads to these points up here. Got rid of the polarity switch that was in the circuit. We added a bias pot to the negative DC bias circuit so that we could adjust the tubes to a proper output. And over here, we sanded away the paint and grounded the speaker output jacks to the chassis. They were originally floating, but now they are grounded to the chassis, just like everything else is. Great. That's gonna about do it for this repair on the Ampeg V4. So stay tuned, and we're gonna do an audio test, and you can hear what it sounds like and how quiet the hum is. All right, here we go with the audio test of the Ampeg V4b. Right now it's on, turned up to almost volume 3, and the tone controls are all set at 0, and there's no hum, no hiss, dead quiet right now. So here's a little bit of what a Fender Jazz bass sounds like through this guy right now. Cool, and let's turn up the volume a little more, get a little breakup. And we'll go back down to 3, and we'll go through the tone controls real quick, make sure they're working properly. Here's the treble. And the mid-range. Control. Well, there you go. I really hope you enjoyed this video featuring the Ampeg V4b. It is a very loud 100-watt tube amp, and now it is very quiet as well. So hopefully you picked up a few tips from this video on what to look for when you have a hum in your amplifier, or maybe that frying egg sound in the background. Stay tuned to this channel for more videos in the future. Please like and subscribe so that they automatically show up in your feed. And we're going to be doing some scratch builds in the near future, as well as a couple more very interesting repairs. So stay tuned. We'll see you.